Okay, first, organization background. Bakerlicious bun is a Malaysian food dessert or side dish that comes in many shapes and sizes, most commonly round and generally hand-sized or smaller. Bakerlicious bun was established in 2020 at Shah Alam, Selangor and began operation on 1st March by Mrs. Hanim. Compared to other bakeries, Bakerlicious bun also has many outflows and entry of money that is conducted on a daily basis and always updated day to day. To do that, they need to have a proper system which can make the sale of dessert and side dishes and purchases of raw ingredients easier. Everyone can access this system, but only a project manager can access the sales and purchase part. This system is used to help us manage our profit or loss every month by summing up the total of sale and purchases. The idea of the Bakerlicious bun came from the project manager Mrs. Hanim, as she struggled to compare the taste and quality of dessert and side dishes from many types of bun. She lead the Bakerlicious bun, who is also the founder of this company. Okay, next. Current system. The organization of Bakerlicious bun is using a manual system as their way to store the information. Bakerlicious bun records every detail of information in book and file. It takes a lot of space to store the book and file. Also, it takes a long time to find the related information when needed. Moreover, all calculations related to sales and purchase are also done manually and ineffective. It's really burdensome for workers to make reports for each month's transaction, as they needed to list each transaction manually. The list of all the supplier and ingredients information may be needed in the future. This information consists of ingredients, suppliers, and costs, so that all the information is likely to be lost when the books and files are destroyed due to disasters such as floods or disappear. This makes it difficult to retrieve the information or the possibility of not being able to find the information again.
I will present about entity relationship diagram known as ARD. Okay, so this is our ARD of bakery database system. Here we have 9 entities with attributes. The first entity is ingredients. This entity is bakery ingredients purchased by employees for use in the bakery shop. The primary key for this entity is ingredients ID. Each ingredient has ingredients name, ingredients price, ingredients quantity, and amount ingredients. The second entity is the purchase. This entity is purchased to buy ingredients by employee. The primary key for this entity is purchase ID. The foreign key for this entity is employee ID and ingredients ID. Each purchase has purchase vendor, purchase product, purchase price, purchase quantity, purchase date, and purchase amount. Third entity is employee. This entity is employees who work in the bakery shop and purchase the ingredients. The primary key for this entity is employee ID. Each employee has employee name, employee start date, employee wage, employee hour, employee phone number, employee address, employee email, and employee date of birth. The fourth entity is sale. This entity is bakery sale that making by the employee. The primary key for this entity is sale ID. The foreign key is customer ID and employee ID. Each sale has a sale date and total sale. The next entity is customer. This entity is customer who buy the product at the bakery shop. The primary key is customer ID. Each customer has a customer name, customer email, and customer membership. The next entity is product. This entity is product sold by bakery shops. The primary key is product ID. Each product has a product name, product type, product quantity, product price, and amount product. The next entity is product customer. This entity is the product that bought by the customer. The primary key 1 and foreign key 1 is product ID. The primary key 2 and foreign key 2 is customer ID. Each product customer has a quantity product customer. The next entity is inventory. This entity is inventory product of a bakery shop. The primary key is inventory ID. The foreign key is product ID. Each inventory has an inventory cost, inventory date, inventory expiry date, and inventory total cost. The last entity is inventory sale. This entity is the inventory sale of a bakery shop. The primary key 1 and foreign key 1 is a inventory ID. The primary key 2 and foreign key 2 is a sale ID. Each inventory sale has a quantity inventory sale. The relationship of each entity in ERD is each ingredient is purchased to one or many purchase. Each purchase is managed by one or many employee. Each sale is making by one or many employee. Each sale is involved to one or more customers. Many product is bought by many customer. Many inventory is allocated by many sale. Each inventory is assigned to one or many product.
Next, we move to database declaration. First, we have table employee. Okay, this is our table structure that include data types and attributes. We have employee ID, employee name, employee start date, employee wage, employee hours, employee phone number, employee address, employee email, and employee date of birth. Next, second table, we have table customer. Okay, this is our table structure that include data types and also attribute. We have customer ID, customer name, customer email, and customer membership. Next, we have table product that include attributes and data types. So we have product ID, product name, product type, product quantity, product price, and total amount product. Next, we have table product customer. This is our table structure that include attribute and data types. We have product ID, customer ID, and quantity product customer. Next, we have table ingredient. Okay, this is our table structure that include attribute and data types. We have ingredient ID, ingredient name, ingredient price, ingredient quantity, and amount ingredient. Next, we have table inventory. This is our table structure that include data types and attribute also. We have inventory ID, inventory cost, inventory date, inventory expired date, inventory total cost, and product ID. Next, we have table sale. This is our table structure that include attribute and data types. We have sale ID, sale date, total sale, customer ID, and employee ID. Next, we have table inventory sale. Okay, this is our table structure that include attribute and data types. We have inventory ID, sale ID, and quantity inventory sale. Next, we have table purchase. This is our table structure that include attribute and data types. We have purchase ID, vendor, purchase quantity, purchase date, purchase amount, employee ID, and ingredient ID.
Now let's start with simple SQL queries. Okay, for the first one, for simple SQL queries, we will use select star from employee. This is to retrieve all of employee data. Hence, we will get the output just like what I show in the slide. Okay, for the second simple SQL queries, we will use select star from customer limit 1, 4, which is it will select all of the column in the customer table. However, it has limited row selection, which only from 1 to 5. For the third one, we will use select employee ID, employee name, employee phone number, employee email from employee, which we will only select column for attribute employee ID, employee name, employee phone number, and employee email, just like you said in the sample output. Okay, now we have select star from customer, where customer membership like member quotation mark percent order by customer name ascending. From here, we can see that we choose all the column from the customer table, but with the customer membership only member, and the customer name is ascending. So we can see here it was start from A and end with N. Okay, now let's take a look at retrieving data from multiple table. So first we have select s.sell.id, s.sell.date, c.customer ID, c.customer name, c.customer membership from cell S customer C, where s.customer ID equal to c.customer ID and customer membership equal to member. So from here we can see that there has two tables to be combined and be produced as one table only. It was from sale and customer table. So from here, where is used where the table has the same thing that we can relate. Hence, the thing that we can relate is customer ID. Since from the sale table and customer table, they both has customer ID. Next, we just choose the membership is member. Hence, we will produce the output has only the member for customer membership. Okay, so this is the sample output. We have select product ID, product name, product type, product price, inventory cost, inventory date, and inventory expiry date from product inventory, where product ID equal to inventory product ID, and inventory total cost more or greater than or equal to 100. So based on the two table, we will combine it to be one table, just like the sample output I show. And then the inventory total cost must be more than or equal to 100. Hence, this is the data that is more than 100. Next, we have select employee.employee ID, employee name, sale.sale ID, sale date, total sale, customer name, customer membership from employee, sale, and customer, where sale.customer ID equal to customer.customer ID and sale.employee ID equal to employee.employee ID, where sale date less than or equal to the date 11/4/2020, order by sale date ascending. So from the three table, we combine to be one table just as the sample output, and the sale date is start from the first month of April. Now let's take a look at Scala function and arithmetic or columns function and grouping. So for the first one, select product ID, product name, product price plus bracket product price multiple with 0.1 as new price from product, where product price plus bracket product price multiple with 0.1 is more than 5. This is the sample output we have, which is have the column for product ID, product name, and for new price only. It does not include with product price because we already make it as a new price. Then the price must be larger than 5. There has select employee IDs, employee name, 8 date, employee start date, interval 24 month in the bracket as wage rest on, employee wage plus employee wage multiple with 0.15 as new wage from employee, order by employee start date ascending. Now as you can see in the sample output, there has only 4 columns, which is employee ID, employee name, wage rest on, and new wage. As you can see before, the wage before is 1,600, but now there has a raise of for 15%, which the new wage is 1,840 ringgit. Okay, and the date is different. It was based on the start work day. 2 years later, then there will be a new wage. Now we have select sale date, sum, bracket total sum as sum from sale, group by sale date, order by sale date. Okay, now for look at the sample output, we can see there are only 2 columns, which is sale date and the sum for the date. So this is to know the total sale or sum for the sale or only for the certain day. Just like the 1 April 2020, the sum for the day is only 280 ringgit. So we can get to know during the date what is the sum for the sale. Okay, now we have select vendor employee ID, purchase date, sum in the bracket, purchase amount as sum, count as count from purchase, group by vendor. From the sample output, we just list down the vendor we purchase from and the total sum we pay to the vendor and the total count of the ingredient we buy from them. Next, subqueries. First, we have select employee ID, employee name, employee hours from employee, where employee ID in. Okay, select employee ID from purchase. which is we only select the employee where they assign in the per case. Hence, we only have 3 employees. We have select product ID, product name, product type, product quantity, product price from product, where the total amount product in bracket select total amount product from product where total amount product less than or equal to 125. Hence, we will get the table or the output only for output because this is the only for that has less than 125. Last but not least, we have subquery from inventory sale and inventory where the inventory sale dot inventory ID equal to inventory dot inventory ID group by inventory ID having average bracket quantity inventory sale greater than select average quantity inventory sale as average from inventory sale order by average quantity inventory sale SND. So for the seller, we have these 3 attributes, which is inventory ID and inventory cost, also average. Hence, we only use the average from the inventory sale, and the order by is from the quantity inventory sale ascending. Hence, the average is from 8 to 50.
Okay, this is all of our simple SQL queries. Next, this is from SQL for retrieving data from multiple tables. Okay, this is our SQL for Scala function and arithmetic or column function and grouping. This is all of our subqueries in SQL. Thank you.